Hey everybody, the purpose of this video is to give you an algebraic solution to question E1 in the measures of center homework. So the question was, looking at a data set in the textbook, what happens if you double each data point? What will happen to the mean and what will happen to the median? I've given you a video that walks you through that particular data set, and it gives you nice graphical interpretations of why both the mean and the median will double. What I want to do here is I want to walk you through it algebraically for a general data set. So if you take any bunch of numbers that have a certain average and a certain median, and you double them, what's going to happen to the new median and mean? And we'll just do the mean. The median's fairly straightforward once you understand the mean. So we'll look at the average. So the original, let's say the original data set. And they have values, but I don't want to make them specific values. I want them to be generalized values. So I'm going to call them x sub 1, x sub 2, x sub 3, all the way up to x sub n. Now this might look terrifying, but it's not. It's just a real quick way of labeling general data points. So x sub 1 will be your first data point, x sub 2 your second, x sub 3 your third, x sub 4, which is somewhere in this ellipsis, x sub 5, x sub 6, up to whatever your last one would be, which would be x sub n. Okay? That's all it is. So this data set may only have two elements, in which case you'd have x sub 1 and x sub 2. It may have 1,000, in which case n equals 1,000. Regardless though, it's going to have an average, x bar, and the average is going to be the sum of all of those x's divided by n. Excuse my phone. And what that would look like, algebraically, would be x sub 1 plus x sub 2 plus dot 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 plus x sub n all over n. Now make peace with that for just a moment. That looks terrifying, but that's just saying whatever those data points are up top, add them all up and divide by how many there are. Fair enough? Good so far. And that's the original data. What would the doubled data look like? Well, the doubled data are going to be twice each of the originals. So it's going to be 2x1, 2x2, 2x3, up to 2xn. And all that means is 2 times. So if x1, for example, was 8, if x1 were 8, then 2x1 would be 16. If x2 were 15, 2x2 would be 30. If x3 were 0, 2x2 would be 0. Perfect. So what would the average now, I'm going to pull this over here actually, what would the average of the doubled values look like? Well, it would be the sum of those doubled values all over how many there are. Now, hang tight for a second. Some of you might be wondering, why isn't there a 2 in the denominator? We didn't double the number of data points, we just doubled the value of each of them, if that makes sense. Hopefully that makes sense. Okay. Now we're going to do something slick here. You see how each of the terms in this sum have a coefficient of 2. We're going to use our old algebra skills, and we're going to factor that 2 out. So if you pull the 2 off the 2x1, you're going to get x sub 1. Pardon the phone. 2 from the 2x2, you're going to get x sub 2. x3, all the way down to x sub n, all over n. Okay, so far, I just factored out that common factor of 2. No big deal. Now here's the cool part. That 2 is now a factor that can be applied to either just the numerator or the entire fraction. You remember that from your pre-statistics days. So I'm going to draw a box around this guy right here. Not including the 2. Not including the 2. Okie doke. Does that box look familiar? X sub 1 plus x sub 2 plus blah 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 plus x sub n. That's the sum of all the data points. But it's interesting, it's the sum of all the original data points before we double them. Divided by n. That kind of looks familiar, doesn't it? That looks just like that. And that is this, and that is this. Which means that really, this entire thing is just 2 times the original average, which is exactly what we were trying to show it was equal to. The question was, what happens to the mean if you double each data point? Well, that's the original mean. If you double each data point, you double the mean. So hopefully, that's a nice algebraic explanation as to why when you double each data point in a data set, you end up with a doubled mean.